Dawson here, and I am going to teach you about simplifying exponents. What are the 4 rules of simplifying exponents? So there's lots of little things we got to learn about with exponents, and so it's one of these topics that could be very difficult and very scary looking. So I'm going to ask you, just don't freak out. Just follow along with me. Really try to pay attention as we go through this. Maybe you got to watch it a few times. That's all right too. All right, so what do we got here? First, let's talk about multiplying exponents, and I'm going to simplify things by just showing you a little bit of the screen here. So when we have a situation where we're multiplying numbers with exponents in them, x to the 4th times x squared, and these could be numbers themselves. It could be 2 to the 4th times 2 to the 4th. As long as the base is the same, so as long as this letter or number here is the same, and we're multiplying, then we can add the 2 exponents together, which would be x to the 6th power. And the reason for that is, if we think about how, or what x to the 4th is, it's x times x times x times x. That's true. Sorry about that. X times x times x times x. That's the x to the 4th part. Times x times x. That's my x squared. Well, doesn't this look a lot like x times x times x times x times x times x? Hey, x to the 6th power. So we can just add these 2 exponents together as long as the base is the same and as long as we're multiplying. If we're adding here, it doesn't work anymore. We can't add x to the 4th and x squared, but we can multiply them together, and then we add the exponents together. Alright, so that's kind of the first little bit of that. And when we do this, like I said, as long as the base is the same, we can put them together. So this is kind of like combining like terms. It's similar in the sense that we're going to put together our x's and we're going to put together our y's. Now let's remember though, combining like terms is when you're adding different terms together. This is multiplying exponents. It's just that it happens to be like it. It's very similar. So if I have, for my answer on this one, it's going to be x to the 6th, because I have x to the 4th times x squared. So that part is x to the 6th. And then here I have y, and don't forget, when you have just one y, it's like y to the 1st, times y to the 8th, which gets me y to the 9th. So that becomes my answers. X to the 6th, y to the 9th. That's simplified. And so again, that's what we're doing here, is we're simplifying these exponents. So when we have to multiply exponents together, we simplify them by writing it this way. If they have numbers in them as well, then we treat it just like we always would, where we multiply the numbers together. 5 times 2. That's 10. X to the 7th, x to the, negative 2. What the, hey, okay, so this is a little bit weird. I got some negative exponents going on here. But, yes, it is true. It is just like saying 7 plus a negative 2. And if we do 7 plus a negative 2, that's going to get us x to the 5th. And we're going to talk a little more about negative exponents in a minute. But for now, yes, we still add them together. Negative 4 plus 4, that's y to the 0. But any number raised to the 0 power is the same thing as 1. So then it's going to be 10x to the 5th in this case, because that just means we're multiplying by 1. We don't have to write that part down. Alright, so that becomes our answer on that one. So again, you can multiply. When you multiply exponents together, as long as they have the same base, you add the tops, add the exponents together, and you get x to the 6th. This one, again, you find the ones with similar bases to them. The x's are the same, so then you add those 2. The y's are the same, so you add those 2. If you have them with numbers, you multiply the numbers first, then do what we had just done before. All right, now Oh, exponents with exponents. Ooh, see, this is kind of looking trippy here, right? You got exponents, but then you raise them to exponents? Okay, that's just a little weird. Well, again, let's just think about what this is actually saying. What is this whole thing raised to the second power? Well, it's saying this whole thing times itself. Alright, so we have x to the fourth y squared times x to the fourth y squared. Because, again, we're just multiplying it by itself 2 times. Okay, so I've got that written down here. Well, we know how to do this. We just were working with this in the last screen. So we put our x's together, we get x to the 8th power. And we put our y's together, and we get y to the 4th power. And we're done. That's it. And you might think, okay, well, that's not too bad, but I wonder if there's a shortcut here. And yes, there is a shortcut. When you raise a power to a power, or an exponent to an exponent, you multiply the terms. So 4 times 2 becomes 8, and 2 times 2 becomes 4. So as long as you multiply those exponents together, you're going to get the correct answer, and this is our simplified version of that problem. If we look at another one, this one again has a number in it, so again, it looks a little more complicated. It's the same idea. 2 to the 5th power, well, that's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. So 32 x, now 4 times 5, that's going to be 20. And y to the negative 3rd, well, negative 3 to the 5th power, so that's going to be multiplying again. Negative times a positive, that's a negative 15. Okay, so now we are just about simplified here, but one of the rules of simplifying exponents is that you can't leave a negative exponent if it's going to be fully simplified. Well, then you ask, what do we do? Well, let me show you what we're going to do. So this is, just before we leave this side though, now we've done multiplying exponents, now we're doing exponents of exponents, or powers of powers. Now let's see what we can do with negative exponents.
Hey Jesse, want to hear a joke? Sure. If you have 10 apples in one hand and 10 oranges in the other, and you take away 1 apple and 1 orange, what do you have?
9 apples and 9 oranges?
No, big hands. Nobody can hold 10 oranges and 10 apples in one hand. Knee slapper.
And this is going to bring in the concept of fractions with exponents. And this is a general rule that if you have a negative exponent, so 2 to the negative 4th power, that is the same thing as saying 1 over 2 to the positive 4th power. Basically what the negative thing is saying here is that instead of multiplying by 2 4 times, what it's really saying is we're going to divide by 2 4 times. And so if I make this 1 over 2 to the 4th, that's the same idea. I'm going to divide by 2 4 times. And so let me just go back really quick. How do we fix this problem then? Because this isn't quite simplified. Well, all we have to do is move our y to the negative 15 to the denominator. 32 x to the 20th power over y. But now, because it's moving to the denominator, we have to change its sign to a positive 15. So this becomes our fully simplified answer for this one. Some of you may say, is that really simplified? But it is. It is in a more simplified state that we could work with a little bit easier. Although that is a pretty ugly number looking thing there. Okay, let's go back to this one. So this is our general rule that you can take a negative exponent, move it to either, if it's in the numerator, you move it to the denominator and it turns positive. If you had a negative exponent in the denominator, you could move it to the numerator and have that be a positive. Okay. All right, so let's look at this one here. We have a situation here where we have x over 3, or x to the third power over x squared. And if we're going to simplify this, which we definitely can, then we can think of it as x times x times x all over x times x. Because this is x squared, x times x to the third power, x times x times x. And we think, oh wait, x divided by x, that becomes 1. And x divided by x, that becomes 1. And so we're just left with 1 times 1 times x. Well, 1 times 1 is 1, and 1 times x is just x. And our answer is just that. But there's another way we could do this. Imagine now we took this x squared and we moved it up to the numerator. So then we had x to the third power times x to the negative second power. Remember, we took a positive exponent and we moved it to the numerator, therefore it becomes negative. You might say, well, what's the deal with that? If we just add these together, 3 minus 2, hey, that is just x to the first power, or just x. So it's in some ways a little bit easier. And once you get really good at this, you look at this and you say, oh, I've got 2 in the denominator. I'm just going to take 2 away from 3. I know that when I move it to the numerator, I'm going to have that be a negative exponent. So I'm going to take away 2 of those 3 x's. I'm going to be left with 1. And you can simplify this without doing any of this work and get right to this answer without having to show any work even. Once you get good at it. But for now, of course, I'll be mean and make you show your work. Okay, well, what about this guy? This guy's got a lot of stuff going on. We have 3 x's here, and we have negative 8, I'm sorry, x to the third power, and x to the negative 8 power, and then x squared. Ugh, there's a lot going on. There's many different approaches on this, but if we start with just the top, and let's just take care of the top. Let's multiply these 2 exponents together, put them together and see what happens. We're going to get x, 3 minus 8, to the negative 5th power over x squared. So we're stuck here and we have to decide, what are we going to do with these? We want it to have a positive exponent in the end, we know that. And so if I take this x squared and move it to the numerator, it's going to become x to the negative 2 power, which is going to give me x to the negative 7 power, but that's a negative. We don't want that. So if I take the negative exponent and I move it to the denominator, then I'm left with positive exponents in the bottom. So then I'm left with 1 over x squared times x to the 5th power. So I'm just switching that x down there and changing the sign so that that's legal. And then I'm left with 1 over x to the 7th power. Okay, well, hopefully that helped you out. And if you have any more questions, watch the video again and then come on in and ask me some questions. All right, everybody, take care and have a good one.